it too. Stay blessed, say less. It's your boy BLK Finesse. We're here to watch what happens if we pour all Earth's water on the sun. I don't think it's gonna do much. You got to think about how big the actual sun is. If we just put the entire Earth's thing of water into the sun, it's not gonna do nothing but just straight evaporate before it even gets that close. But I want to see what they got to say, how much research they did on it. Let's check it out.
Is it possible to put out the sun?
No.
For example, what would happen if we poured all of the Earth's oceans on it? Or even more water? Well, let's find out.
Okay, more water maybe, but not
The
the Earth's
universe
water.
is a place full of mysteries. Since ancient times, scientists have been arguing about how space works. But none of us has ever doubted the existence of one thing, the sun. The center of our solar system. It's big, bright, and immortal? Nah, not really. Actually, the sun is just an ordinary star. It consists of 75% hydrogen, a little helium, and a pinch of other heavy elements. Gravity holds it all together. But in around 5 billion years, the life cycle of the sun will come to an end. The hydrogen inside it will run out. Our star will begin to grow gradually, and you can't even imagine just how big it will become. And then it will start eating all the nearby planets. That's when we'll regret being so close to it. After eating us all, the star will remain a red giant.
Yeah, see, that's the main point I'm talking about. Like, if you try to put, I don't really think it's going to do anything to the sun, considering that literally once it gets big in like 5 billion years or something like that, it's going to evaporate all the water before it even gets close. Like, it's really no chance the sun's really going to lose its fire or helium and all that heat. At least I want to say literally all the planets is not going to be able to diffuse the sun.
Billion years or so. And then, sooner or later, it will begin to shrink and fade, turning into a white dwarf. In the end, nothing will remain of it but a bright and colorful planetary nebula. But don't get scared. Right now, the sun is in the middle of its life cycle. It was born about 4.5 billion years ago, and about the same amount of time remains. Fortunately, we were born during the star's best and most stable period. In other words, there's no reason to worry. So let's find one. How about speeding up the sun's life cycle with the help of water? We'll try to collect all the water on Earth and pour it onto the sun.
It's not going to do
First,
anything.
We'll need a bucket. No, not this one. We'll need a really, really big bucket. The one that can contain around 326 million cubic miles of water. It will be equal in size to the distance from Washington to Chicago. Or if we can only find ordinary buckets, there should be around 70 quintillion of them. This is a number with 18 zeros.
Thanks.
Okay, imagine that we magically got that many buckets. It's time to put out the sun. We splash the star with all this water and nothing? Seriously?
Nothing.
Just look at this. The sun has probably felt sorry for us and produced one little solar flare. It turns out that all water on Earth is actually just a pathetic drop for the sun. People often underestimate how much bigger the sun really is than our planet. In reality, it can fit more than 1,003,000 Earths. So yes, the sun won't go out or even get colder. It won't even notice that we've done something. But let's not give up. We really want the sun to go out for some reason. What happens if we pour just enough water on it? And how much is this enough?
What is just enough?
Remember our quintillions of buckets? Well, we actually need about 370 octillions of them. This number has 27 zeros.
Yikes.
It's hard to even imagine, so let's just say that it's a lot of water. Now, let's splash it all over the sun again. Wow, just look at the steam. But the sun hasn't gone out again. On the contrary, it said thank you and suddenly became much bigger and brighter. What's happening? You see, the sun isn't actually a campfire. Inside bonfires, candle flames, there's a chemical combustion. When we pour water on the fire, the water absorbs the heat of the flame and cools it to such an extent that it can no longer maintain the burning reaction. It also blocks the fire's access to oxygen. Water basically stops the chemical process. But the burning of the sun isn't the same reaction. Even though we say it burns, it's not entirely true. What happens there is called nuclear fusion. It's one of the most violent and craziest reactions in the universe. There are many layers of hydrogen going deep into the sun. If you take 4 hydrogen atoms and ram them together, you're left with an atom of helium. When we talk about the sun, the process is a little more complicated. When the star tries to carry out that fusion, positive protons repel each other.
To be honest, I'm starting to think you need water the size of the sun. You're not going to find any kind of water with that much amount anywhere in the universe, in my opinion. Like, you have to have a super, super large ice giant. But anything larger, it gets hotter. So, I mean, I don't know.
Of force and energy to somehow squeeze them together. Fortunately, there's a magical force in space. It's gravity. The sun takes up 99.8% of all the mass of the solar system. Pretty heavy, right? And all this mass is what holds the sun together with the help of an incredible gravitational force.
Are you driving way less than you used to? Do you have a clean driving record? Are you over 25?
So,
and that's the crazy part. It's not even a solid, bro. Like, inside the sun, yes, it's solid, but the sun together is just straight liquid.
Gravity
like,
takes quadrillions of these little hydrogen atoms and pushes them together every second of every day. And when they collide, they release some energy. So, unlike fire, the sun doesn't need oxygen to live. It needs hydrogen. And we all know that water is H2O. It consists of hydrogen and oxygen. So this is literally fuel for the sun.
Yikes.
It's like trying to put out a fire with gasoline. More importantly, the extra mass added by water will make the sun heavier. Now, gravity says, thank you for your help. And then it starts to collide protons with each other even faster. And thanks to this, the synthesis speeds up.
That's crazy.
Great, we've made the sun incredibly strong, and now it has eaten us, along with other nearby planets. And if we keep adding water, the sun will sooner or later collapse in on itself. It will blow off its outer layers and become a black hole. Awesome. Now it will pull inside absolutely everything around.
Yikes. Okay. I didn't realize it was going to do that. I didn't know that just making it heavier just off of water, it collapses. Okay, so the more water you put on it, the heavier it gets. And just constantly fueling it, the bigger it gets. But I think it needs to be a lot bigger. The sun isn't that big. I think you would need a good amount of water to make it that heavy.
Good job, guys. Let's press rewind, because clearly our water experiment was a mistake. One small solar flare sounds much better. Alright, we're back to our usual calm sun. But it seems like there's something that we've forgotten.
What's that?
Apparently, water was critically important for life on Earth. Who would have thought? Now there's a huge amount of unmoving fish and other marine creatures lying around where the oceans used to be. Fourth.
You know what? I want to know something. With no water on the Earth, what would actually happen if we went to the very, very, very bottom trenches? Would we have some kind of gravity or pressure or something? Or would nothing happen? Because I know that gravity is a thing. I guess the closer you get to the center of the core, I guess more pressure is on you. I want to know if that's the same thing with water.
As for deep sea creatures, they simply didn't withstand such a sharp change in pressure. Algae and corals have also dried up. Wait a minute, weren't they responsible for producing 50 to 80% of the world's oxygen?
Yikes.
Oops, it's time to put on some oxygen masks. And how are things on dry land? I mean, now everything is just land. But you get the point. Wow, this whole place is lit, and I mean it literally. If there are no oceans, then there are no clouds or rain.
Yikes.
Now there are forest fires everywhere. Poor animals have to escape and leave their homes.
Why is there forest fires?
And it's not like they'll be able to find a new home, because all plants, of course, will dry up quickly. There will be literally no place for living left on the planet. So now Earth looks like a giant desert. Great!
Like
people
Mars.
have been living in deserts for thousands of years, right? Maybe they'll know what to do. They won't. After all, people in the desert also need to drink. So now there's total chaos everywhere, and survivors fight for the last drops of water. If there are any survivors at all. In fact, no matter how much they fight for resources, their fate is sealed. The ocean absorbs a huge amount of CO2 and the heat coming from the sun. They also distribute this heat throughout the planet, making it pleasant to live on. But once they're gone, the temperatures will quickly jump to 250 degrees Fahrenheit and above. But even if we forget about the high temperatures, now we have no clouds, and they helped us too, by not letting through solar radiation.
Sheesh, I didn't know water
we're also
itself
under the
is
direct
that
impact
cold.
of the sun's rays. Our last hope is icebergs. Now that everything is terribly hot, they've melted. And maybe they'll be the last hope for humanity. But that cool solar flare was definitely worth it.
Okay, so that literally explains what I just said. The sun's not gonna be able to go out if we put all the Earth's water on it. For one, it's just that small, just a little drop. I want to know if they hopefully Brightside would be able to make something like that if they put all of the cold components of all planets onto the sun and see what it does. You feel me? See what it does. But if not, that just means it's just that much heavier. But comment, like, down, subscribe down below, so good luck. Finesse, we out.